Okay. Fine. Okay. Now, just let me remind you what we are discussing right now. We are talking about differential equation, first order. And we mentioned that we have two methods, in general two methods, analytical method and numerical method. Numerical method to be discussed in level 3. Now, for the time being, we are discussing analytical method. We already discussed direct method, separable method. Now, today we will start with another method, which is the exact method. Let me start from the principles and then I go to the definition, then we solve a problem to be easy. Have a look. Let's assume we have function z, which is function of two variables, x and y. Now, definitely, when we want to differentiate, we will differentiate partially x, as you can see here, with respect to x, and partially with respect to y. And if this function equals c, sorry, when we differentiate c, it will be 0. This is almost the general form for exact equation. And if I want to give example here, have a look at this equation. This is z. Now, if I differentiate the whole expression here with respect to x, it will be 2x, 5xy, it will be minus 5y. I keep y as a constant, 5 constant. And y to the power 3, it will be 0. Its differentiation with respect to x. dx plus, I differentiate it again with respect to y. So x squared, it will be 0. Minus 5xy, it will be minus 5x. And y to the power 3, it will be 3y squared, as you can see here. dy. Now, this is the general form for what we call it exact matrix. Let me put it in a definition. If I have m, where m is function of xy, dx, just a minute, m is dx parameter, okay, plus n is dy parameter. This is what we call it exact equation. This is how it look like. Or if I want to make it very simple, I will say m dx plus n dy equal 0. M is dx parameter or element. N is dy parameter. This is what we call it exact differential equation. Okay. Now, one important issue to be mentioned here is to be exact is not only enough to be like this, in this form. No. We need to differentiate m, which is dx element, with respect to y, and differentiate n with respect to x. If they are equal, we say this is exact. So this is condition, need to be satisfied. Have a look. When I differentiate m with respect to y, and I differentiate n with respect to x, I say this equation is exact equation. I can solve it using the procedure for exact equation. Now you may ask, okay, what if the condition is not satisfied? We cannot solve it by exact. We need to go for another, let me say, step to do something to make it exact, and then we back to exact, as I will explain, inshallah, next session. Now I will skip the proof. You can follow the proof, it's easy, but I want to go to the example directly, because with example it will be easy. Okay, let's solve this problem, but let's first have a look at it. He told me to solve it. I can see here there is expression dx plus expression gy equal 0. What coming to my mind directly that, oh, this look like exact equation. I can say that this is m and this is n. It look like exact equation. But I need to check. I need to see if it is exact or not. I need to satisfy the condition. Now I will differentiate this m with respect to y. So 2xy, it will be 2x, right? Because, I mean, 2x will be constant. I differentiate only y. Partial, you see here? Partial m over partial y equal 2x, I keep them constants. Differentiation of y is 1, then that's it. Okay, comma, partial n over partial x equal. Now, if I come here, this is n. When I differentiate it, 2x, x squared will be 2x. 2x. Minus 1, it will be 0. So just a minute. 2x here, 2x here, they are equal. So I say, okay, this is exact. Done. Now, until now, I know that my equation is exact. My equation is exact. I satisfy the condition, then I solve. By the way, just I will pick the method of solution, then I will apply it. The method of solution say the function, the original function, because what we are doing is solving differential equation. It means returning to the original function, which is when we differentiate, we got the differential equation. The function f equal to integration m dx. I took the first element with respect to x, you see, plus I need to add function to consider y. So I will say gy. It could be whatever we call it, gy, zy, whatever we call it, doesn't matter the name, but it's function of y. Now, next step is to differentiate the function f, this one, with respect to y, because I integrated with respect to x, I differentiate with respect to y. So this part, this part, already differentiated with respect to y. And this part, when I differentiate this function of y, it will be g dash y. Next, I will equate all parts here to n. Just a minute, I integrated here with for m. I need to equate for n the opposite, yeah. Then I came, definitely this part to be taken to the other side will be in minus, as you can see it. I integrate g. I integrate it to find g. I got it. I take it and back substitute here and equate the whole expression to c. This is the solution. Oh, I lose my way. Yeah, definitely. With the numbers, with example, you will find it very easy and clear and straightforward. Have a look. Let me back to the function here. Now we agree that this is exact equation. Its form is m dx plus n dy equal 0. I satisfy the condition, okay? And I know where is m, where is n. Now let me come to do the, let me say, the solution. I will take this 2x y dx, as you can see here, and integrate. This is the solution, dx. And this is the function g of y. I've been talking about it. Now, integration of this part with respect to x, it will be 2x squared y over 2. 2 with 2 cancel. What is left? X squared y. Plus g, all this equal, let me say, c. This is the solution. This is the solution. One more issue, I need g. What happened? I don't know, the pen is not working. Sorry, something wrong happened. I will close it and open it again. Okay. Um, Um, can you see the slide? Hello?
Yes,
Yes,
doctor,
yes.
Okay.
Yes,
Okay, now it's
doctor.
back. It's back. Okay, it's back. Unfortunately, I'm working from home. This is my son computer, so I'm trying to use it. So, okay. Now, where we are? Okay, we are here. So what we did, we say this is equal to C. Now this is the solution. Got it? This is the solution. What is left is to find G. Okay. Now what we say this is integration of M dx. So what I will do, I will differentiate the function here, you see, partially with respect to y. I integrated with respect to x. I will differentiate with respect to y. Okay? Now when I will differentiate x squared y, it will be differentiation of y is 1. So what is left? X squared. And differentiation of g is g dash. Okay. Now here I integrated m, then I need to equate to n. Where is n? Just a minute, let me back to the equation. This is n. Okay. I equate to n. Okay. Oh, most of the time you will find some similarity on the right and left hand side. You can simplify, cancel. I cancel this one with this one because they are the same. So I end up with g dash equal minus 1, as you can see. When I integrate g dash with respect to y, it will give me g equal minus y plus c. I take this part and substitute it here. As you can see here, x y squared, the first part, minus y c, the second part, equal to a constant. As you can see here, to constant, I call it c dash, c1, c a, whatever you call it. Now take c here to the other side will be minus c, and combine them, it will be c dash. Take y as a common here. What is left? X squared minus 1. Divide by x squared minus 1. I got the original function. Now it's a procedure. If I would like to put it, okay, as steps, I will say, okay, I have function in this way, or equation in this way, plus n dy equal 0. I need first to make sure that the condition is satisfied, which say partial m over partial y equal partial n over partial x. If I satisfy it, I say, okay, this is exact. I go to the solution. The function f equal integration m dx, the first part here, plus g of y equal c. The result should be equal c. And the second step, I differentiate f with respect to y now, and equate the result to n. Okay. Next, I integrate to find g of y. Okay. I'm back to substitute it here. This is the solution. There is another prospect we can look at it, is rather than I integrate m dx, I integrate n dy. What will happen? I mean, until here, the same solution. But rather than this, I will go in this direction. I will say, okay, f could be integration of n dy rather than m dx, n dy. But I need to add function. Since I integrate with respect to y, I need to add another function. I call it h of x. Great. Then you see here, I differentiate it with respect to y. I will say, okay, differentiation of f with respect to x. The opposite. And equate. I equate it to m. No, I will equate to m. The opposite. Then I find h of x. And substitute here is the solution. Okay, let's take this example to clarify this. It means I can go in either direction. Both of them will take me to the solution. Have a look. He told me that this is the equation. This is m, clear. This is m dx, and this is n dy. Now let me take m and differentiate with respect to y. When I differentiate this with respect to y, exponential to y, it will 2 exponential to y. Exponential minus y cosine xy. Oh, this is like uv. You remember uv? When you differentiate, will be uv dash plus v u dash. So I differentiate first the cosine. It will be minus x sine xy multiplied by y. So I reach here. And I differentiate y, it will be 1, so it will be directly minus xy. Now this is partial m over partial y. Now let me do partial n, this n, over partial x. I differentiate this part, then this part will be 0. I got the same expression. I will say, okay, condition was satisfied. It is exact. Now I will go to solve it. You remember in this example, when I came here, I integrate m dx. M dx. This is m dx. Now in the second example, I will try to integrate n dy. This part. Okay? Working in the other direction. So 2xy here, exponential 2y, I put it in this way. You see, x, 2x, I put them outside the integration because they are constant now. I'm integrating with respect to y. The same thing for the second part. I put here x because I'm integrating with respect to y. 2 outside. I'm integrating with respect to y. And I added function for x. Now integration of exponential 2x is 1 over 2 exponential 2x, 2 with 2. What is left is x exponential 2y. Now, integration of cosine will be sine, but I need to provide 1 over x, so x with x, it will be 1 directly. And this one, y, it will be y squared over 2, 2 with 2, what is left is y squared. Now, just don't forget, please, this is the solution, equal C definitely. This is the solution of the exact equation we are talking about, all this equation. This is its solution. What is left is I need, again, oh my God. Okay. 1 second. Still, you see the slide?
Yes, doctor.
Yes, doctor.
Great,
Yes,
great,
doctor.
great. Okay, great. I'm using the mouse. It's really difficult. So this is the solution. As you can see here, equal C. This is the solution. There is only one more issue, is to find h of x. Okay. Now here I integrated with respect to y. Okay. So what I will do, I differentiate with respect to x. It means this one, differentiation of x, it will be 1, so direct exponential to y. Differentiation of sine x, y, it will be cosine. Differentiation of y squared, it will be 0 because there is no x, and h dash. Okay. I here integrated n dy, so I should equate to m. Where is m? This is m. I brought it, put it here, as you can see. Let me check if there is something I can cancel. Yeah, I can cancel exponential here and here, y here and here. What is left? H dash of x equals 0. When I integrate, okay, to find h, it will be constant because constant when we differentiate will be 0, as you can see here. Now I take this c and substitute. Where is the equation here? You see that all this part will become c, let me say, or c1. I will call this c1, this c. So this is the solution. Another problem. Now it's given in this way. Directly I will do cross multiply in this way. So my function become here. I will say, okay, this part represent m. By the way, if this is exam question, work in this way. This part will be n. I need to check if it is exact or not exact. I will differentiate m with respect to y. Just a minute, cosine x sine x, there is no y here, 0, this is 0. Minus 2xy square, with respect to y it will be minus 2xy. Okay. What about this one? Y by 1, just a minute, it will mean y minus x square y. I enter y here to this part, to this part. Now when I differentiate with respect to x, this will be 0, this will be minus 2xy again. Oh, it's exact, done, it's exact. Now I can apply the formula. I can apply the procedure. Sorry. Now I will come. Okay. Let me take this part. N. It's easy. Rather than cosine, sine, blah blah. I go directly to this part. When I integrated this part this way, pi. Okay. Minus x square y dy plus h of x. This is n, right? When I integrated y, it will be y square over 2, x square, y square over 2 also, h, okay? Then, you see here, 1 over 2 outside y square, and this is h of x. Now, I differentiated with respect to x now. When I differentiate with respect to x, I got this one, minus x y squared, because this one will be 0, okay? H dash. I equate to m. Where is m? This is m. Where is it? Yeah, this is m. I equate it to m. Just a minute. Is there any similarity? Yeah, this is cancel with this one. What is left is this part. I take it and integrate it. Cosine, sine. Just a minute. I remember this trigonometric. I'm talking with myself. Trigonometric table. 12 rules. I go for them. I find the solution. Plus c. Now I have h. Let me back. Where is h? This is h. I substitute here. You see? Equate to c. Simplify as much as you can. As example, here there is 1 over 2, 1 over 2. Multiply everything by 2 and simplify more. C, take it to the other side, will be minus c. Make it a new constant. I have here formula. Simplicity. Now he told me in the question, okay, he gave me initial condition. He told me when x is 0, y is 2. Great. This means I can't find c. Okay. I will come here. Where is it? Here. X is 0. Wherever x there, I substitute by 0. And wherever y here, I substitute by 2, it will be 4. Simplify. We found c dash equal 3. I back to substitute here. This is the final shape. You got it? Is it clear? Is it clear? Ladies, gentlemen?
Yes. Yes, doctor, yes.
Yeah. So if it is clear, I will try to pick a problem from the next lecture. Just a minute. If I have here one problem, I will pick one problem. Just a minute. Linear. No, I don't have. Let me pick from the book. Okay, just a minute. It's not here. Where can I find this? I will pick example from the internet. Differential equation, differential. Oh, this one. Exact. Okay, let me see this one. There is example. Yeah. Okay. Just a minute. Where is the print? Okay. Solve differential equation. I will take this one. Just a minute. Which one is easy? Okay, this one. Copy.